Hi everyone, welcome to Ms. Sawagid's math class. We learned last lesson about relations and functions. We learned that a relation is a function if every input has exactly one output in an ordered pair, table, and from a mapping diagram. We also learned in a graph, the graph will pass a vertical line. If it passes that vertical line, that means it is a function because it did not pass more than one point on the graph. Today's lesson, we will decide whether this function is a linear function or nonlinear function from a graph, table, or an equation. Now, how can you decide whether the function is a linear function or nonlinear function? We'll start with those two examples. To find the circumference of a circle or to find the area of a circle with a radius r. Let's start with the circumference. Here's the table and here's the graph. Let's see what happens. The equation of a circumference is 2 pi r, 2 times pi times the radius. Now, since the radius is changing from 1, if the radius is 1, what would the circumference be? Substitute 1 in the equation, and I'm going to only show you the first one. C equal 2 times 3.14 is pi times 1, which is the radius. And that gives you 2 pi if you leave it with pi without substituting the 3.14, or 6.28. So put that in the table. If the radius is 1, then the circumference will be 2 pi. But if you multiply that 3.14 times 2, gives you that 6.28. Do the same thing for the radius 2, 3, 4, and 5. Multiply the radius by pi or multiply the radius by 2 and then find the answers. And here's the table. Now graph it. Now let's think about the area of a circle. The area of a circle is pi r squared. That means multiply pi after you square the radius. So the area equal 3.14 times, let's try with the first example when the radius is 1. So 3.14 times 1 squared, so 1 squared is 1, times 3.14 gives you 3.14, or just leave it as 1 pi. If the radius is 2, substitute the radius by 2, and 2 squared is 4, 4 pi, or 4 times 3.14. Now let's graph it and see what happens. The area depends on the radius again. Plot every point and see what happens. And now connect the points on the graph, see how it curves up. So what's the difference between linear and nonlinear function? Now let's discuss linear functions from a table, graph, and equation. From a table, look at the table. Look at the radius. How did the radius change? From 1 to 2 to 3 to 4 to 5. It increased by 1. How did the circumference change? It went, let's talk about pi because we don't want to subtract the decimals and see what happens. From 2 pi to 4 pi to 6 pi to 8 pi to 10 pi, how did that change? It increased by 2 pi every time. So there's a constant pattern, and that's what linear function. If there's a constant pattern, it's a linear function. Every time the radius increased by 1, the circumference will increase by 2 pi. That's a pattern. It's a constant rate of change. Now look at the graph. Did it create a straight line? Yes, that is a linear function. Now look at the equation. C equal 2 times pi times the radius. The equation is written in the form of y equal mx plus b. Now let's talk about nonlinear functions. Look at the table from the radius and the area of a circle. Watch how the radius increased by 1 every time, and the area did not increase at a constant rate. There is no constant rate of change, which means it's a nonlinear function. Now look at the graph. Watch how the graph curved. It's not a straight line. That means it's not a linear function or nonlinear function. Now look at the equation a equal pi r squared. Watch how r is to the power of 2. That means it cannot be written in this form of y equal mx plus b. Therefore, it's a nonlinear function. Now here's the table. How can you distinguish between linear function and nonlinear function from an equation, graph, or table? In an equation, the linear function can be written in y equal mx plus b. Nonlinear function, you cannot write it in the form of y equal mx plus b. In a graph, the graph of a linear equation is a non-vertical line. It is a line, but it's not a vertical line. The graph is not a straight line. Table has a constant rate of change. That would be linear. If it does not have a constant rate of change, it's nonlinear. Now look at those two graphs. Does the graph represent a linear or nonlinear function? Explain. Remember, if it makes a straight line, it's linear. If it doesn't make a straight line, nonlinear. So the first one is nonlinear function. The graph is not a straight line. It shows a curve. The second one is a linear function. The graph created a straight line. Now, look at the tables. Does the table represent a linear function or nonlinear function? Explain. Again, if you can find a constant rate of change, that means it's linear. If you cannot find a constant rate of change, it's nonlinear. So look at the table. Watch how x increased from 3, 6, 9, and 12. It increased by 3 every time. And the y went from 36 to 30 to 24 to 18. That means it went down by 6. So every time x increased by 3, y decreases by 6. So there is a constant rate of change. In the second table, watch how the x increased from 1 to 3 to 5 to 7. It increased by 2. And the y from 2 to 9, that increased by 7. From 9 to 20, increased by 11. From 20 to 35, increased by 15. So there is no constant rate of change. That means it's a nonlinear function. Now let's decide if the equations are linear function or nonlinear function. Does the equation represent a linear or nonlinear function? Explain. Remember, if you can write the equation in the form of y equal mx plus b, then it is a linear function. The first one, isolate y to write in the form of y equal mx plus b. See how y is isolated on one side of the equation by itself. So isolate y, get rid of everything by the y. And since you have the x and the 3 on the same side as the y, get rid of those two. Always get rid of the variable first. It makes it easier for you. Since you're subtracting an x, add x to both sides, the addition property. You will end up with y plus 3 equals 2x. Now, subtraction property of inequality, get rid of the 3 by subtracting 3 from both sides. You end up with y equal to x minus 3. It is a linear function because it's written in a y equal mx plus b. Now the second example, y equal 3x over 5. Separate, y is already isolated, now separate those numbers. It means 3/5 x, which means it is in the form of y equal mx plus b, but this time b is 0. Number 3, y equal 5 minus 2x squared. Right away, it's nonlinear because x is to the power of 2. You can't write it in a y equal mx plus b. Number 4, x equal 9. There is no y, which means this is a vertical line crossing the x at 9. And if it's a vertical line, then it's non-linear function. It's not a function. It is linear, but it's not a function because it will not pass that vertical line test. So when you have x equal, it's not a function because you don't have a y. Now, the graph of a linear equation in two variables is the set of points x and y, and those are the solution, where x is the domain and the y is the range. In a coordinate plane, that represents all solutions of the equation. Sometimes the points are distinct, and other times the points are connected. So what's the difference when you see a graph with points by themselves or a connected line? And that's where we come into something called a discrete domain. Domain is the x. Look at this graph. There's only dots on 1, 2, 3, 4, and 5, which mean the domain x is 1, 2, 3, 4, 5, only integers, no decimals, no fractions. Look at the graph. Also, there's dots. So the domain in the solution, x and y, again, the domain is the x. Starts from 0, and then 1, 2, 3, 4, 5, 6. Those are the domain or the values of x in the solution. Now, a continuous domain is a set of input values that consist of all numbers in an interval. Look at this number line. It is continuous from 1 to 5. Everything in between 1 and 5 would be a solution or the domain in the solution or the x. So the domain x is a compound inequality joined by with the word and. It has an interval from 1 to 5. And that's how we write it. X more than or equal to 1, less than or equal to 5, because those are closed circle. Now look at the graph. Watch how it's a continuous line. So the domain is a continuous domain, and the domain is X. So again, it's a compound inequality. The linear function y equal 15.9x represents the cost y in dollar of X tickets for a museum. Each customer can buy a maximum of 4 tickets. So the domain is the X and the range is the Y. Find the domain of the function. Is the domain discrete or continuous? Explain. Again, the domain is X. I'm going to continue saying that so you guys don't forget. Since you can only buy 4 tickets, that means the domain can go up only to 4. But can I buy half a ticket? Can I buy 2.5 tickets, 3.5 tickets? Or does it have to be an integer, a full ticket? Yes, and that's how I know it is a discrete domain. That means I cannot buy half of something. So the domain would be 0, 1, 2, 3, and 4, and that's it. Graph the function using its domain. So if I know what X is, substitute the value of X in the equation, find Y, which is the range, and that gives you the ordered pair. You can make a table, okay, you can do it in your head, that's fine, and then graph it. And all these points on the graph are the solutions for this equation, and that's why you only go up to 4. Here's another real-life application. A cereal bar contains 130 calories. The number of calories consumed is a function of the number B of bars eaten. So the number of calories depends on the number of bars eaten, which means B is independent, which is the number of bars of cereal. Does this situation represent a linear function? Yes, it does. There is a constant rate of change. Every time you consume a bar, you add 130 calories. You consume 2 bars, that's 260, and go on. Find the domain of the function. Is the domain discrete or continuous? Explain. Domain is the number of bars, or B. Can I consume half a bar? Yes, you can. So decimals are included, which means it's going to be a continuous domain because you can have decimals in the domain. You can consume 0 bars to however how many you can eat. So the domain is the X of the number of bars consumed. Can be 0, starts with nothing, 1, 2, 3, up to infinity, how many you can consume. So the domain is X as long as it's more than or equal to 0. To graph it, graph the function using the domain, make a table, but you don't need to go to infinity. Just try the first 4 or 5 numbers of a domain and graph it. But make sure you connect those dots because this is a continuous line. In conclusion, examples of discrete domain in real life, as long as you have an integer, were numbers without decimals or fractions. For example, if you talk about people, can I cut it to a person in half? Or can I have a 3.5 person? You can't. Those are discrete, so you have to have the integer or the full number of people. Another example, when you need to come up with your own examples for real life, such as items sold in packs or dozens. Now, examples of continuous domain in real life could be any number, whether it's an integer or a decimal. For example, number of pounds you buy from the store, apples, tomatoes, whatever you're trying to buy from the store, or the miles driven in your car. But you still have to think about the content of the problem when it comes to real life. For the example, look at the gallon of milk and a gallon of gas. Are they discrete domain or are they continuous domain? Think about, can you buy half a gallon of milk from the store or 2.2 gallons of milk from the store? No, which means those are discrete domains. But the gallons of gas, when you go to the gas station, you can buy 1.5, 1.2, 6.8 gallons of gas in the gas station, and that would be a continuous domain. So think about the situation in real life for you to come up with your own examples. That's it for today's lesson. You guys have a great day.